All right, everybody, we are back to do some nomenclature for test 2. And as you're about to see, the nomenclature is a little different than, well, I clicked on the wrong spot. Let me see where I am. There we go. Might not see it ever if I can't get the screens to share. Here it is. It's different than other tests. You're supposed to provide both the molecule and its name. And let's get to the part I can write on. Here it is. In a way, it's easier because you're going to pick, I hope you're going to pick simple molecules, but in a way it's harder because you really have to know everything about your functional group. So we better know how to draw a carboxylic acid. This one seems to show up on every test. And don't draw a big one, please. You can call that ethanoic acid or acetic acid. That name is so common, you have to learn it. Acetic acid. And I'm going to try in every example that I can to use acetic acid as the parent molecule, starting with our secondary amide that I'm going to draw here. It's going to have acet in its name, and it has to have a nitrogen, and it has to have at least one more carbon. Why not a methyl? And you have to say that it's N-methyl. And it's not acetic acid anymore. It's acetamide. That's how you name amides. You lose the ic acid, replace with amide. There, ic acid gone, amide in its place. Now, to make a lactone, I can't use acetic acid because a lactone has to come from a molecule that had both a carboxylic acid and an alcohol. Acetic acid doesn't have that. But I can start with, lactone is cyclic ester. Draw the simplest cyclic ester you can. That's a pretty good one. And name that based on the acid. The acid was how many carbons? I think it was 4. And it's butanolactone. But you must tell me where it closed. Where was the O that closed the ring? It could have been on 3, and that would be a different one. I'll just draw it and erase it very shortly. If it was 3-butanolactone, it would look like this. Be a square, and the 4th carbon would be there. That comes from the same, from butanoic acid, but this would be 3-butanolactone. That's not the one we drew. The one we drew was 4-butanolactone. If you want to use the Greek letters, it's fine. Remember, alpha is the first away from the carbonyl, beta and gamma. You could replace 4 with gamma. Replace 4 with gamma, and that's red. It's okay. Put that up there so you know. Okay, and you forgot what gamma was? It's right here. Alpha, beta, gamma, delta, epsilon. What was that one again? I'm embarrassed to say I forgot what that one was. Zeta? I think it is. Yes, we have to know the other ic acids. I'm pretty sure this was captured on video. I said you better know how to draw any of the common ic acids, and I listed them. I'll relist them right now. You better know how to draw nitric acid, sulfuric acid, and phosphoric acid. They're all acids we use. Phosphoric acid. That is P-double-O. With 3 O's attached with single bonds. This is the nature of all phosphates right here. Now, what do you think diester means? Well, it's got 2 esters. That's what it means. That means it needs 2 R groups instead of hydrogens. And that O, I will accept either O minus for the other O or OH. If you do the H, then all you have to say is diethyl phosphate. That's how you name esters. Name the groups attached to the O's. Separate word, name the acid, but change its name to ic acid to 8. Okay. And if you made an O minus there, you'd have to say diethyl phosphate monobasic. And we don't want to add words. We want to keep it as simple as possible, right? There we go. Now, what are you going to do with an S epsilon lactam? Oh boy. Lactam is a cyclic amide. Have to know it. Epsilon. Alpha, beta, gamma, delta, epsilon. So what I'm going to do on the right here is draw something that could make an epsilon lactam. It has to be a carboxylic acid before it started. And then there's alpha, beta, gamma, delta. Epsilon has to have the nitrogen. It doesn't say it has to have groups on it. And that could make our lactam. 1, 2, 3, 4, 5, 6. That's alpha, beta, gamma, delta, epsilon. There's going to be a stereocenter involved too, because I want you to make it an S epsilonolactone. Lactam, sorry. Lactam, not lactone. And remember, if you start over here with one more carbon, you've already got a stereocenter. And you can name it after this parent molecule. Oh, I wish I could count properly. It's a heptanoic acid. It's going to have hept in its name. And you're stuck about how to name lactams. Well, let's see, lactones. They end with lactone. And heptanoic acid became heptanolactam. And it's going to be S. Some of the naming was done for you, by the way. S epsilon heptanolactam. And all you have to do is make this ring. You have to do a dehydration reaction within the one molecule. You got O, and you got 1, 2, 3, 4, 5, 6. And then the nitrogen is going to close the ring. Still has an H. And the extra carbon is out here on a stereocenter. Please make sure that stereocenter is S. Right now it would be R if the 4 was on a dash. And by putting the 4 on a wedge, it's an H there. How can I make it show better? Put in green or something. That's just so I can see that it's an H. There you go. S epsilon heptanolactam. And that would be 2 points because of the stereocenter. 2 points if there's a stereocenter or easy geometry. Good. And 2 points for this one because it's an E nitrile. Well, the E has nothing to do with a nitrile. That's for the alkene. That's all we use E for. We draw a simple E alkene and then put a nitrile on the end. 1, 2, 3, 4. So it's 2-butenonitrile. 2-butene-O nitrile. And tell me it's E. Right there. And as promised, you better know how to draw nitric acid, and then you better know how to do derivatives. Nitric acid, an ester of it will have the H that used to make it an acid. You got to put an R there in its place. That's how we do esters. You take the H off an acid and put an R there, just like here. I took the H off phosphoric acid, put an R. I'm going to take the H off nitric acid, put an R. Lewis means you better pick the smallest possible molecule, or else it won't fit in this box. Nitric acid is a cool molecule because it's got the nitrate ion in there. Says Lewis, lone pairs, not an option. You got to put them on. There's nitrate. Instead of an H, I'm going to put an R. How about a CH3? And it's Lewis. Don't get lazy on me. I got to see all bonds and all lone pairs in the Lewis structure. Methyl group attached to nitric acid in an ester is methyl nitrate. Yeah. Then we're going to draw a cyclic anhydride of succinic acid. And this is something one of the students was mentioning in class, and I never got to it. And I said I was going to. I feel bad. I know who she is. So if you see something like succinic acid, then you got to think such. These are the diacids. But this is our lecture instead. The expression goes, oh my such. Oh my, such good. Apple pie. It's a cute little expression. Oxalic is the first diacid. So how many carbons does oxalic has if it's a diacid? Each acid has one carbon, and this is the smallest one, 2 carbons. Remember, you're 2, 3, 4, 5, 6, jeez, 6, 7. And oh my is malonic. We better know malonic. Malonic. Succinic, glutaric, adipic, and pimelic. So here's succinic acid with 4 carbons and 2 acids. It is not your answer here. It's how we start our answer. 1, 2, 3, 4. Carboxylic acid number 2 on the other. I'm trying. Carboxylic acid number 2 out here. Looks terrible. How do you make an anhydride from 2 acids? You get rid of water and connect what's left. So you got a carbonyl. CH2 once. How many CH2s in the middle? 2. Then a carbonyl. And then connect what's left. That means connect this O that I didn't quite circle. It looks like I may have circled it by mistake, but I can't move it. Have I moved my molecule? It did. I'm going to connect the O to the other carbonyl. I haven't drawn the O yet. Here's the O. Here's the other carbonyl. Cyclic anhydride of succinic acid is succinic anhydride. Ha! That's the easy part. And that's a good preview of the nomenclature section on our test. We got about 3/4 of it done. All right, so I'll see all of you in class on Monday, and have a great weekend. I will come back and see if Ali has more questions. And till then.